All right, for our video today, we're going to talk about fused and non-fused disconnects and why we use them. In our last video, we talked about insulation piercing connectors and how they connected directly to the wire that was running from the meter. And then we said our other option was to use a breaker, which would be a load side connection. Now, a breaker is what's called an overcurrent protection device. That means, or OCPD. That means that if too much electricity is flowing through that breaker, it'll trip and shut off, and that protects the wires. It does not protect the devices. It's meant to protect the wires in the circuit. So that's the overcurrent protection device. Now, if we have a breaker that's backfed, then it'll go to a disconnect, then it'll go to our inverter. Now, when we use a breaker, we'll use this kind of disconnect right here. It's a non-fused disconnect. We connect wires up at the top. We connect wires up at the bottom. This switch might... Let me turn it up, and you see those little blades? Bam, they snap into place. Pull them back down, they snap out of place. There's no fuse there. This is not an overcurrent protection device. This is just for disconnects. This is a fused disconnect. We insert our wires up here, and then we insert our wires up down here. And as you can see, the difference is there's a fuse here. There should be a fuse here, but there's not. But there's a fuse here. Now, this fuse is our overcurrent protection device to make sure that if too much electricity flows through, these will break and stop it and protect our wires. We use this type of disconnect on a system that has a load side or a line side tap and no breaker. The breaker acts as the overcurrent protection device in load side connections, and we use this type of disconnect. On line side connections, we use this type of disconnect, and these fuses act as our overcurrent protection device. Happy Friday, all.